Good evening YouTube and all my viewers, Ian here from Coolice charge cases and power supplies. I'd like to obviously give you another quick video if I can of the current charge case on my desk or on my bench or on my floor, because it's actually quite big, this one, so it doesn't quite fit on my bench underneath where the shelving is and stuff. So basically this one is for a UAV company. The previous video I uploaded obviously brushed briefly onto it in that it needed to be kept not watertight but weatherproof would be a good word to use. So everything is so far being kept inside. The cooling fans are, and cooling fan shrouds if you like, are designed to allow water basically just to run off them. So if this case is caught out in a rain shower, because it's going to be a hard working case in this instance, then it won't matter. The case will obviously just keep going. The lid can be closed if it's not already closed, and the case will just keep ticking along quite nicely. Done a little bit different with this one. The MPA boards are sunk into the deck, like I have done before on other case builds. Again, this is another byproduct of using the thicker 10mm polypropylene decks. It allows you to do a little bit more with it. Excuse me. But because the customer also wanted the ability to have batteries on charge and be able to close the lid of the case at the same time, I wanted to put the batteries just that little bit lower, just to give me that little bit more room, because the case I've chosen doesn't necessarily have a deep lid as such. There are ones that are deeper. So what I've done, I've created two 10mm polypropylene decks if you like. The upper deck, the upper plate if you like, has the cutout to suit, and then there's a secondary deck which is bolted directly underneath the top deck. So again, it's 10mm lower, but that is the deck then that has the MPA board recesses cut into it, and the shape of the cutouts then are obviously changed around a little bit to allow this quite large, I think it's a 1600 milliamp hour LiPo pack for the quad, to obviously sit in this recess on, and two, one on either side of each MPA board, and there are two boards going to be mounted in this case, so that they then sit on the deck slightly lower, and it allows the lid to close. Now this case isn't 100% finished yet. I've got a couple of additional wires to make up. There's a bump controller in there, which is quite nice. So there's going to be leads going from, I need to make up leads to go from the two planned PL8s that are going to go into this case to channels 1 and 2 of the bump. And then, as with the previous video I've got, and I've uploaded it, there is then going to be the additional channels 3 and 4 going to the external input with the magnetic flap lid on the front of it as well. So I need to create up another couple of leads for those, and I'm thinking again as well about making them quick release from the underside of the deck as well. So it just, at the moment with the current cases that I'm building, I like to keep as much as I can on the main deck itself and keep all the main wiring to that, and limit the amount of wiring then going from the deck itself to the power supplies that are inbuilt into the case. And normally the power supplies themselves then are directly bolted into the bottom of the case, so they're nice and secure. They're not going to go anywhere if the case gets dropped or mishandled by usually aircraft baggage people in this case. So without further ado, let me see if I can turn this phone round and start showing you the case. Now it's on the floor. Oh, lost my shoe. Not very much to see on the outside. I'm going to obviously laser etch my little plaque that will sit in this recess here, so that will just finish off the outside. We've got the obligatory rotary isolator switch. Now that's going to obviously be able to decouple the power supplies that are inside the case. So when the customer then wants to use external DC input, using the side port, which as you can see here is here, and that's the magnetic flappy bit. So you'll see the two little slots at the top, they will have female servo connections in. So my plan is to have obviously port 3 of the bump controller at the top, and then port 3 the next one down, and then obviously then the EC5 input, DC input power, or DC output power even, at the bottom there. And again, like with the other video, oh, It's magnetic, so it won't just flap up easily. You have to just hook your finger in there. There's a little recess there to break the magnetic clasp. And then at the back is that all important waterproof mains connector there. And I've got the plug, I've got the lead made up actually. I can get that, keep it on the case. There's the plug for that. It's quite nice. It's obviously a release thing. I've only ever tried it once or twice so far from memory. Haven't tried it since it's been in. Let's try it. It's all down, so it's got to go like that. So once it's in, it's going to go. A bit difficult to do. There you go. You heard it there. Potentially there's a proper little click to it, and it's actually kind of spring loaded on the outside. You can just about see the outer shell moving, so as you pull it, it should then unclip. And there's O-rings there, you can just about see them, so that's what keeps it watertight. But anyway, let's pan back a bit. Oh, got the man reading there, or the electronics guy reading there from CPC. Let's open it up, and there we go. So as you can see, usual kind of deck with the carbon fibre film on the front. But there, you can obviously see there straight away, you can see the step. So there's the top layer of 10mm polypropylene, and then you've got another layer of 10mm directly bolted underneath it. I'll try and add some photographs at some stage as well, and then of course then it's the bottom layer, then it's got the cutouts for the MPA boards. Now obviously I've got one, so that's the way it's going to go. The customer is either going to send me his MPA boards for me to fit, or because he needs them for work, I'm actually making it that he should be able to retrofit these himself. The hardest part realistically, he's going to be cutting the connector off the end and soldering on another 4mm bullet to plug into the front of the PL8. So if he's down for that, I can obviously send him pictures of how to do this and instructions, and he'll be good to go. So basically, if I've got one of my rather nice Align 60C lipos, because it's roughly the same it's roughly the same depth. If anything, actually it's a bit deeper than the packs that he showed me. So the idea is the balance connections on the AMPA board, they're sub flush, so that the battery then can sit on top. Obviously his one's about that same sort of width, so it'll then obviously sit on there like so. And I've made it so that with his battery there, and it's about 174mm long, so obviously it needs that clearance at the back. So with the battery then sat here, he'll have one here, one on the other side, and again it'll be about here. And I've made it so that the front two balance connection points on either side of the MPA board here are the ones then that will be free to plug his balance lead into to charge from. And then of course then his lead, then I've got little caps on the Dean's connectors there on the top of the MPA board. But basically when he's charging smaller packs, he'll have the option then to put the 6 packs around the MPA board quite reasonably unhindered, obviously apart from the ledge, apart from the 10mm ledge. But then when he's charging his big daddy packs for his UAV, they will sit there, they will cover the back two MPA balance board connections, and then leave the front sets here free for him to plug into. So that'll be quite nice. And they'll basically then the height of his packs then will work out, I'm led to believe, like that. So the whole plan was then to be able to do that, which you can. It's not pressing on the lid, so that's quite good. So obviously then in theory you can have that floating around outside. It can rain, it can do whatever, and rain and the water isn't going to affect the battery charges that are going to be going on inside. That was one reason for having I suggested the bump controller when we were talking about the spec. He said, oh, I'd really like to be able to close the lid if it starts to rain on light. And knowing lipos in general, you kind of go, you really want to be seeing those lipos as they're charging. So if you really need to, or if you really want to be able to close the lid, let's give you some other way to monitor those lipos where they're charging. And realistically it's that, because he can visually see on his phone, tablet or computer even once the Windows software is available from Revo Electrics, what those batteries are doing. And for safety's sake, I might even look at putting, for what they cost, might even look at putting some form of smoke detector as well in the lid or something. That might be another little thing to do. If I can get a small one that fits there, that'll work out quite nice. I'll see what he says. But otherwise, that's going to work quite good. I mean, I'm pretty confident, to be honest with you, 90% of the time the lid will be open on this. That's the way it'll be. But on those odd occasions when the guy is out on site and the company needs to earn its money, the batteries will be charging and he can just come along and say, right, no, it's raining, close the lid, and then let them finish off charging, and then obviously then say, right, okay, let's just put it in the back of the van kind of thing so we can open the lid up again or whatever. But at least they're not going to be caught out. So I wonder if I can very carefully, if I remove my battery and move my light without dropping it, I wonder if I can take this out. Be quite nice if I can. Let's see if I can flip it over. Yep, I can. You can see, sorry, there's the wires then from the MPA board that's mounted on top. A 3D printed, these little spiders, as I call them, down the middle, and there'll be another one for the other side. So the middle band of screws, if you like, they bolt into this, and obviously it acts as a clamp on it. And obviously I've made it all joined so you don't have to, so when the guy puts it together, or me even, he doesn't have to worry about putting individual nuts on each screw, because that would be a pain in the behind, that would. As per normal then, I've gone with the 3D printed brackets for the PL8. So if I get my one here, I've got an empty shell one actually, admittedly, so that will sit there. 3D printed bracket, one there. Where's the other one? Where's the other one? And there's the other one. And then obviously another one then on the other side. Have I got them right? Yes, I have. So they'll be there. They'll bolt down. I've put some extra little spaces actually there with some felt backing on there so it doesn't mark the charger. And of course then, probably can't see it, but there, yeah, with the screws there, I've again 3D printed. You can probably hear the 3D printer going in the background. Was it printing some more spares? I've 3D printed some MPA spacers, so we're putting aside the white ones that come with the board as standard, and then we're using these, which I've created the right height so that the so that the M3 bolts that I'm going to supply are just the right length, so they just come through that little clamping spider there, so they won't interfere or touch the top of the charger, hence the 5mm spacer there. Just spaces it up a bit, so that's going to work out quite nice. Let me put that there so I don't lose it. I'm going to give him some spares. Bump controller on at the front, of course it's recessed so that fits in there, and then obviously the 3D printed clamp, which obviously just clamps on either side. It's recessed at the back as well, so I can get the leads in when it comes around to it. I also then put a little bit of a relief there if we needed to get a USB connection in there, but of course now the bump controller can be updated via Bluetooth, so we don't need to. I've got some 3D printed clamps here. There'll be ferrite rings on the signal connections going from the bump controller to the charger. So there'll be a ferrite ring here, obviously coming from the wire here, ferrite ring wrapped around it, little loop of wire again, ferrite ring here, and then of course then the short length of wire then going into the port in the back of the charger. And then of course then bottom left hand corner, or it would be bottom right hand corner when it's up the right way, we've got the usual USB twin charge port here. Then I've got my main power points, so one of these wires, that's going to be the wire, the connection down then to the bottom of the case, and the power supply is in the bottom of the case. And then they're a bit loose at the moment. I'm going to obviously put some clips there, so that's going to be 25-volt power wire to one PL8, and then 25-volt power wire then to the other PL8, which will be at the back here. I've got some little plastic P clips that I think I'm going to put underneath these securing bolts. These black bolts here, I'm not going to count them on camera, but all these black bolts here, they are clamping this second layer onto the front layer, if you like, The good thing about that is then obviously it beefs it up, makes it quite strong, which is quite good. So not a terrible amount to see yet, but you can see obviously the MPA is recessed here, so the MPA there does obviously sit down into the recess. Quite nice. That's done that before. The M5 inserts, again, these screws, they're not drilled and tapped into the plastic. They're actually the M5 inserts are screwed into the bottom layer of plastic, and then these M5 bolts then screw into the brass inserts. Gives quite a nice grip. You know, you're not, if you then have to take the screws in and out a few times, you're not worried about stripping the very fragile plastic or the softer plastic, because obviously they've got a metal insert in there, which is quite nice. Let me see if I can swing the my empty Coke bottle. It's been quite warm here in the UK. That's the inside of the case. Usual power supply, server power supplies there, and obviously with my custom connection balls at the front. Rotary isolated switch. Obviously all the nuts are loose at the moment in case I need to add to it. That's the clamp then for the outside assembly. The back side of the waterproof connection with AC, and of course then they're the waterproof fans that I've come up with. So they're the brackets to hold it. Then if I close the lid and turn it round, I think I did show this in the other video which I've uploaded, or should have uploaded before this one. That then comes to the 3D printed shrouds at the back again. So as you can see, the idea being, as it rains on it, the rainwater will then just drip off, and they're below there, they don't protrude outside of the case ribs, so the case ribs will take any abuse. The case gets thrown around and the shroud's there, and as you can see obviously this case is wheeled, which is quite nice. Got a little rubber dust cap there on the AC, so that's quite nice. Weren't cheap that AC plug there, you can see it on the floor. All in total I think that was about 36 quid from RS Components, but it'll do the job quite nicely. So I'll leave it there. Thanks for watching, and stay tuned for more charge case builds from Coolice charge case and power supplies. Take care. Bye bye.